All right, we're going to look at a couple examples. They're two of my favorite ones. Example one is pulling out a tablecloth, and then I'll show you a video of that. And then example number two is the pen and the Coke bottle example. All right, so we're going to watch this. They're so excited. Yeah, as an advertisement for a BMW motorcycle. So the first one you saw was legit. The guy had a tablecloth. He had a couple dishes on it, and he pulled out the tablecloth. And what we'd say is, in that case, those dishes had inertia, because when you have like a massive ceramic plate and a bottle, those things are objects at rest. They want to stay at rest. So you pull the tablecloth fast, and they want to stay behind. The part, and I don't know if I should ruin the surprise or the ending or not, but when they did that example with the motorcycle or the dirt bike, I guess it's a motorcycle. They did actually do it, but they did a trick. And I think maybe we'll watch the Mythbusters, or maybe you can figure out how they did it. They kind of cheated the system. In the first case, when they pulled the tablecloth with the dish and the bottle on it, that was legit. But the second thing with the motorcycle was not legit. That was kind of a little cheat to it. So, all right, the pen and the Coke bottle. I'll skip ahead here. So Kayla Rand here is going to show you the demo, how to do it. And then I have a former student of mine, Mason, who in 2019, he failed at first, but then he gets it on the second attempt. So we have the Coke bottle right there. We have the crochet hoop, which you can get from Walmart. And then you have the pen, and I took the bottom part out there. You can see it's flat now. The toughest part is getting that pen to stay on there, and it just takes practice. You want to make sure your crochet hoop's round, and if for some reason you can't get it to stay on one point of the crochet hoop, just like rotate the crochet hoop and put it back on the bottle, and then put it in a new spot on there. Okay. You could talk about Newton's first law. The object at rest wants to stay at rest. You could probably, for every action equal and opposite, because you have gravity pointing down and normal force going up. So you could probably even tie F equals ma, Newton's second law, if you wanted to somehow. So I will say, when I was a rookie teacher, I didn't like doing this in front of the class because I felt like I'd get nervous and I'd pull the hoop, and the pen should drop straight down. But the goal is you want to pull from the center dead horizontally. And you just got to be careful, and you got to go quick when you decide. If you put your hand there, pull dead horizontally. I'm going to do it, but I'm going to wobble the phone here. So not to show off, but there you go. I'm not going to lie. The first video I sent you didn't have it in there, so I didn't send it. So there you go. Crochet hoop, pen, Coke bottle. Okay, Mason, how you feeling right now?
I feel great.
All right. All right, so you're going to start with your hand inside the hoop?
Yep.
Fast, fast, fast. All right, this is Mason's second attempt.
All right, here we go, guys.
Use two fingers.
Fast, fast. Class right there. How do you feel on the inside? How does your heart feel right now?
I feel great.
There it is. All right, Newton's first law. The biggest takeaway about Newton's first law: can you use it, using Newton's first law, to describe the function of a seatbelt in a car? So think through: an object in motion wants to stay in motion, an object at rest stays at rest unless acted upon by an outside force. Like, how does Newton's first law apply to why you should wear a seatbelt? So go ahead and hit pause and think that through, and we'll come back. All right, so here's the deal. You're cruising in your car. So say we have this person right here, and she's belting herself in. Say that person's going 70 miles per hour in their car, and their speedometer says 70 miles per hour. Well, that means that everything in that car, including the person's going 70 miles per hour. And if, like, say an animal were to run in front of your car, or there's something on the road where you had to slam on the brakes, well, all of a sudden your car's velocity is going to go from 70 down to 0. And you, being an object in motion, you need some kind of outside force to stop you from moving. Well, the seatbelt right here has been designed to provide an outside force that's survivable for a human being. Now, if you didn't put the seatbelt on, there'd be no outside force from the seatbelt to stop your motion. So the next thing that could potentially stop your motion would be the steering wheel or the windshield. But the only thing is those things can't provide a great enough stopping force. So then the people become objects in motion. And I'll just show you a video. This is from the Insurance Institute for Highway Safety. So we have a car going into a wall, and this is with no seatbelt. It says, how fast do you think the car is traveling? So look at this, how fast do you think they're going? No seatbelt, no airbag. And in that case, the outside force is being provided by the windshield. And here's take 2 where you have an airbag and a seatbelt. This is 35 miles per hour, by the way. And I don't know about you guys, but 35 miles per hour does not feel very fast when you're going 35. And that's 35 on the top with no seatbelt. So that's why you always want to wear your seatbelt, because according to Newton's first law, you need something to stop you if you're going 35 miles per hour, and you want the something to be a seatbelt. You don't want the something that's stopping you to be a steering wheel or a windshield. So just promise me always wear your seatbelt. Newton's first law. All right, we'll close out with this today. Non-physics types. Maybe they never took physics class, but in this case, you have a car. Their car is stuck in a big pile of snow, and we're Minnesotans. I know we could figure this out, but picture you're stuck. You're an object at rest. You want to stay at rest. So in order to move, you're going to need an outside force. So think through, if you ever got into this situation, how could you prevent yourself from ending up on YouTube like these poor fellows here? But how would you get unstuck? So you're stuck in a big snowbank. You have you and maybe like 4 or 5 friends. How could you get unstuck? What are ways you could get unstuck? So just brainstorm those. Hit pause. We'll come back and give you some ideas. All right. So over the years, when I've asked this question, I'll have a student say, well, Mr. Laurent, you could just try to rev your tires and get out. That usually works. Well, if you're in enough snow, that's not going to work because there's not a big enough force from your tires. So one thing you could do, probably the most straightforward answer would just to say is to dig out the snow, right? Like maybe you have a shovel and you just dig out the snow so you're not stuck anymore, would be a good idea. Some people talk about that you're going to kind of rock the car with your friends. So maybe they're going to push it, and then you're going to maybe like put your car in reverse, and they're going to push the car as you kind of accelerate out. The big thing with that you always want to be careful on is that you want to make sure your friends are pushing one way and your car is not driving towards them, because that could be dangerous, right? If you had your car going the wrong way. These guys, however, are going to hook up a tow rope. So you can see there's a rope right here. And what they're going to do is they have a truck with a lot of horsepower, and they're just going to say 1, 2, 3, and they're just going to accelerate. But the problem with that is that this car has mass. And if this car has mass, that means it has inertia, which means it has a willingness to want to stay put. So the car basically wants to stay where it's at. So watch what happens when you pull too fast. And I always say just be careful, because like this car is going in reverse. So if you ever have friends, make sure you're not standing behind the car, because that would be dangerous. And you can kind of hear them accelerating. I've edited out the swear words. Says, if you wreck my bumper, I'll something. So he's accelerating really, really fast. You shouldn't be doing that. And then the truck's going to pull really fast. And that's the inside of his trunk right there. Super slow motion here. He just opens up his trunk. Just trying to help you never end up on YouTube in one of those videos like that. If you were going to pull this car, you would want to hook it up to the actual frame of the car and then pull slow and steady. Well, the person who was in the car would also accelerate slow and steady. But those guys they're going all in. They're accelerating just way too fast and too hard. All right, we covered a lot today on Newton's first law. We talked about Sir Isaac Newton. We talked about Galileo. So just go ahead and before we go here, try to answer these 4 questions and just see what you take away from today. And then we'll be ready to learn about Newton's second law in our next video. So, all right, thanks for watching. Have a great day. Go physics.